GoLang Variadic functions. This is part of the GoLang tutorial series created by Navin Ramatan, which has a great series about GoLang and an amazing blog series about GoLang and additional topics. So GoLang Variadic functions. What is a variadic function? Functions in general accept only a fixed number of arguments. A variadic function is a function that accepts a variable number of arguments. If the last parameter of a function definition is prefixed by ellipsis, ... then the function can accept any number of arguments for that parameter. Only last parameter of a function can be variadic. We will learn why this is the case in the next section of this tutorial. Syntax. Example function hello receives first argument an integer, and the second argument ... int. This is the type of the second argument, which means it's a variadic and can accept multiple ints. In the above function, the parameter b, the second one, is a variadic since it's prefixed by ellipsis. By ellipsis, we mean the ... and it can accept any number of arguments. This function can be called by using the syntax, either call the function with 2 arguments because it's receiving 2, or just use commas and treat it as if it's accepting multiple arguments. So if our function name is hello, then hello 1, 2, or hello 5, 6, 7, 8, 9. Though the function receives only 2 arguments, but the second argument is variadic. In the above piece of code, we call hello with the 1 argument 2 for the parameter b, and we pass 4 arguments 6, 7, 8, 9 to the b in the next line. It's also possible to pass 0 arguments to a variadic function, so we can just pass the first argument, which is not variadic, and that's it. In the above code, we call hello with 0 arguments for b. This is perfectly fine. By now, I guess you would have understood why a variadic parameter should be only last. Let's try to make the first parameter function variadic. The syntax will look like, so we use the ... on the first parameter, and then we take another parameter which is not variadic. In the above function, it is not possible to pass arguments to the parameter a, because whatever argument we pass will be assigned to the first parameter b. How can we tell if this argument is for the first parameter, if the first parameter is variadic or not? Hence, variadic parameters can only be present at the last in the function definition. The above function will fail to compile with error, syntax error, cannot use ... with non-final parameter b. Examples and understanding how variadic functions works. Let's create our own variadic function. We will write a simple program to find whether an integer exists in an input list of integer. Function find. The first argument is standard, and the second one is nums ... int. The way we access the ... int is with a for loop. For I, v, range of nums. Basically, we apply the range function on the argument that is variadic. In this way, we get the index of the variable and the value of the each variadic function. In the above program, the function find accepts variable number of arguments for the second nums parameter. Inside the function find, the type of nums is actually an array of int, an integer slice. The way variadic function works is by converting the variable number of arguments to a slice of the type of the variadic parameter. For instance, in line number 22, in the example, the variable number of arguments to the find function are the number of arguments that we passed in. The find function expects variadic int argument, hence these 3 arguments will be converted by the compiler to a slice, which is basically an array if we're coming from different computer languages. Slice here means array, and then it will be passed to the find function. When we have not passed any arguments to the variadic parameter, then this is perfectly legal. The argument, the parameter of the variadic function will be nil, slice, with length and capacity of 0. So when to use slice arguments versus variadic arguments? You should definitely have a question lingering in your mind now. In the above section, we learned that variadic arguments to a function are in fact converted to a slice. Again, to those who are not in GoLang, slice means an array. Then why do we even need variadic functions when we can achieve the same functionality using slices? I have rewritten the program above using slices. Basically, instead of variadic functions, we have here a slice, an array. So the following are the advantages of using variadic arguments instead of slices. 1. There is no need to create a slice during each function call. If we look, so the client, the code that calls the functions looks cleaner. If we look at the program above, we have created new slices during each function call. This additional slice creation can be avoided when using variadic functions. 2. We are creating an empty slice just to satisfy the signature when we have no parameter to pass. Then instead of creating an empty slice array, we can just pass no arguments. So far the arguments were cleaner code. This is totally not needed in case of variadic functions. 3. I personally feel that program with variadic functions is more readable than with slices. Yeah, it tells you I can accept 0 or more arguments, and actually I don't really mean here an array of 1000 arguments. I mean here a couple of arguments. At least the meaning. Append is a variadic function. Have you ever wondered how the append function in the standard library used to append values to a slice accepts any number of arguments? It's because it's a variadic function. Append, accept a slice to append to, and then accepts elements ... to append to. The above is the definition of append function. In this definition, elements is a variadic parameter. Hence, append can accept variable number of arguments. Passing a slice to a variadic function. Let's pass a slice to a variadic function and find out what happens from the example. So we have a function that receives a variadic argument, and we are going to pass it with a slice. We are passing a slice to a function that expects a variable number of arguments. This will not work. The above program will fail with a compilation error, cannot use nums as a type int to argument of hide. Why doesn't this work? Well, it's pretty straightforward. The signature of the find function is provided below. According to the definition of variadic function, nums int means that it will accept a variable number of arguments of type int. Nums, which is a slice of int, is passed to find function, which is expecting a variadic int argument. As we already discussed, these variadic arguments will be converted to a slice of type int, since find expects a variadic int argument. In this case, nums is already a slice of int, and the compiler tries to create a new slice of int. The compiler tries to. So it's trying like twice to convert the input arguments to arrays. So is there a way to pass a slice to a variadic function? The answer is yes. There is a syntactic sugar which can be used to pass a slice to a variadic function. you have to suffix the slice with the ellipsis, ... So if we are going to use a slice, an array, and suffix it with ... we would be able to pass this slice into the function. If that is done, the slice is directly passed to the function without a new slice being created. In the example program, the program will compile and print funny because we are passing it a slice with the ... suffix. So we create a slice nums, which is a slice of int, and then when we call the function, we call it with nums ... in the argument itself. Gotcha. Just be sure you know what you're doing when you're modifying a slice inside the Variadic function. So if we treat the Variadic input argument as an array and do s square bracket 0 and change it, what do we think will be the output of the program? If we think about it, it will actually be different because of Variadic functions and slices. We are using a syntactic sugar ... and passing the slice of Variadic argument to the change function. As we have already discussed, if ... is used, the welcome slice itself will be passed as an argument without a new slice being created. Hence, it will be passed and be changed, so it is using the same array, the same slice inside the function as the one that is passed to it. So when the function is updating it, it's actually updating the same reference. So this is it for Variadic functions. Again, this was a blog excerpt from Navin Ramanathan with his great blog series about the GoLang.